Traditionally, we use mud-based construction. In Nepal, especially in the mountain areas, we still have about 70% of the buildings is a mud-based buildings, mud constructions, either stone in mud, adobe, and sun-dried brick buildings, rammed earth, or other types of the mud-based constructions. Trend is changing, but still the buildings are not getting disaster resilient. They're using modern materials, for example, cement-based and steel materials. They, at one hand, are easier for maintenance, but at the other hand, they are still not disaster resilient, and then they are very poor in thermal comfort. So, considering the climate change issues and then fluctuations in temperatures and others, the thermal insulation is one of the very important parameter to make the climate resilient buildings. In this research, we propose non-erodible mud, a concept of improvised mud plaster to make the buildings fire resistant, climate resilient, and also earthquake resistant. Let me explain the non-erodible mud first. This is just a slight improvised or slight, making the mud plaster more flexible using bitumen cutback, rice straw, and the clay and sand mixture. We still use some bitumens, but the ratio is so low that it's about 1:25. For example, if 25 kg of the mud, then 1 kg of bitumen, something like that ratio. So ultimately we use very small amount of the modern materials, and then mostly we use the mud. The improvised mud, there are techniques on that, and then it's the non-erodible mud is tested in some of the laboratories, and also Nepal National Building Code includes the provisions of non-erodible mud for both for fire resistant as well as for the mud plaster in the wall. What we propose in this study is this non-erodible mud for making thatch roof, which is one of the very good insulation system, roofing system, to make that fire resistant first of all. The second, we propose this to use as a mud plaster so that the maintenance issue is reduced and the comfort is still ensured. And also we propose to use this for the seismic retrofitting of the mud-based constructions so that we can retrofit those buildings in a very low amount of cost. What we propose is the non-erodible mud, the terminology is already there in the code, but in terms of the practice it's not there. So our innovation here is we propose to build a prototype building with thatch roof. We use this non-erodible mud and then continuously evaluate the thermal comfort. At the same time, the durability of this system from the environmental issues, so that we can spread those messages of the comfort as well as the durability to the wider people. At the same time, we propose to demonstrate this technology in several buildings, and then again the difference in terms of the thermal comfort as well as the maintenance issues will be continuously monitored, and those informations will be collected in a developed the mobile app continuously from the users. They will feed the data, and then once we have those facts, we can give this message to the wider audience through different awareness raising, the tools and methods.
This is the overall architecture diagram of our system. First, the data from various sources are collected and they are transported to the server through various medium. After that, in the cloud database, it is analyzed to create a new model, and then the model is used to produce various output, which is then visualized and monitored through web application as well as mobile applications. For the data collection phase, there are various sources. As mentioned earlier, we require various data like geographical information, building information, and other data. So the data sources, we have various data sources for these data. First is the optional, which provides the demographic data, and then the enumerators also provide various data through COBO toolbox and COBO applications. Also, the primary data source would be the environmental sensors like air quality sensors and temperature sensors that monitor the building temperature as well as the surrounding temperature and feed it to the cloud server. These data are then sent to the cloud server and stored in the cloud database. So this is the overall framework of our application, and we will develop it in various phases. First phase will be the survey by train enumerators to using mobile app, and the biosensors that provide the data needed for our model. After that, the data is stored in the cloud database with regular monitoring and analysis. With this data, we will be generating predictive models and validate it to measure desired outcome from data collected from the pilot houses. In phase 3, we will be developing updated version of the tool with additional data from additional houses. And in the phase 4, we will be developing the predictive models and test, validate and integrate with the mobile application and web application that will be used by policymakers as well as house owners for their own purposes.
So that this simple technique, cost effective, technically reliable, economically affordable, the culturally acceptable, because mud-based construction is already accepted, so that this sustainable, climate resilient, disaster resilient technologies in the wider audience and the wider the people. So this is what our proposal is. Thank you.